Hey everybody, this is Ecology and Ecosystems Part 3, so here we go. Now we're going to talk about some cycles in this little PowerPoint. The first one is the water cycle, and basically the water cycle is just the circulation of water on the earth. So you get fresh water that's evaporating from bodies of water like rivers and lakes and even oceans, and then basically it goes up into the air and then it comes back down as rain. And eventually it's going to return to the oceans over time because all rivers, and bodies of water that are freshwater eventually do return to the ocean. Now, the human impact, basically the water cycle, is affected by groundwater mining, and that's just when water is pulled up out of the ground, and that can cause a lot of problems because the aquifers, or basically the underground water sort of caverns, are being drained faster than they can be naturally replenished, and so you have problems with sinkholes and basically the ground being really unsteady. And did you know that fresh water only makes up about 3% of the world's supply of water? Okay, and so it's very important to maintain our groundwater because it keeps the ground nice and firm. Okay, it's also, of course, good for the soil. Now, here's the water cycle, and it looks kind of complicated, but really, you have had this before, I know, in earlier grades. Basically, if we start on the left here, you do have ice that melts, like in Antarctica or around the northern pole. And so that's going to evaporate from the ocean. It's going to go up into the air, and eventually it will come back down as rain. Some of it will get transported by wind, and then some you get from the soil as a form of evaporation, and some you get from plants from transpiration. That's just basically, water that comes from the soil and plants. Okay, kind of evaporates. And then eventually, that water that comes up from the plants in the soil will come back down as water as well. Some of it will sink into the aquifers, or kind of these underground water areas, and that will become groundwater. Some of it will go into lakes. Some of it will go, of course, into for plants and farming and all that. Eventually, though, you'll get a lot of freshwater runoff, and then from deltas and tributaries, and eventually it will all kind of return to the ocean. So that's really the water cycle. Now, the nitrogen cycle. The nitrogen cycle deals, of course, with nitrogen, and nitrogen gas makes up about 78% of our atmosphere. And plants really can't use plain old nitrogen gas, and so they have to be able to have nitrogen in another form. And so nitrogen fixation happens with cyanobacteria and bacteria that live, that are free living or live on the roots of certain plants, like legumes. Okay. And so basically you get nitrogen gas being converted over to ammonium, and plants can use ammonium ions as well as nitrate, as a source of nutrients. And bacteria are going to make organic compounds containing nitrogen so that the plant will be able to make proteins and nucleic acids and other nutrients that it needs. Now, nitrification, that's just a product of nitrates that plants can also use, and you get nitrogen gas being converted to nitrate by, basically lightning or cosmic radiation that we get, meteor trails, things like that. And so ammonium in the soil is also converted to nitrate by nitrifying bacteria. Okay. Now, denitrification is when nitrates go back to nitrogen gas, and nitrogen gas really is unavailable for plants to use. Now, nitrogen can be added to fertilizer, and runoff, or basically like chemical dumping that contains nitrogen, contributes to eutrophication. And eutrophication, that's excessive richness of nutrients that are in a lake or other body of water that's frequently, of course, due to runoff. And the effect causes a dense growth of plant life, and also it can cause animals to die for the lack of oxygen. So it can make lots of algae overgrowth and lots of plant overgrowth, and basically make it to where the animals will die off because the animals will not have enough oxygen in their body of water that they're living in. And then fertilizer use also results in the release of N2O, or nitrous oxide, which is a greenhouse gas. N2O is a component of acid rain. It's also a contributor to ozone shield depletion. Okay, and fertilizer also has phosphate in it, and phosphate will run off into lakes and result in algae overgrowth and also fish kills. So the nitrogen cycle is really kind of a delicate balance, because if you get too much um, nitrogen, from fertilizers or chemical dumping, anything like that, it can cause animals to die in the water. Okay, and basically it's just kind of pollution. And so here we have nitrogen gas in the atmosphere. We have nitrification. Okay, so basically decomposers are changing ammonium, well, actually nitrogen to ammonium, and then to nitrite to nitrate. Okay, and plants are also helping with that as well. And basically, the nitrate eventually turns back into nitrogen in the atmosphere. Okay, and you tend to get also nitrates being changed back into ammonium, because there's really just a delicate balance that's going on here. Okay. You don't have to know lots and lots of details about this, but just kind of know the big picture. Now, the carbon cycle. The carbon cycle, basically photosynthesis is going to take up carbon dioxide from the atmosphere, and that's what plants use to make more oxygen for us. Now, the reservoirs of carbon are really just like fossil fuels, things like coal, petroleum, natural gas, shells and limestone, and then decomposing or dead organisms. Now, the problem with carbon dioxide is that more CO2 is being deposited in the atmosphere than is being removed, and that's due to deforestation and fossil fuel burning and really just pollution. And increased carbon dioxide in the atmosphere contributes to global warming. And carbon dioxide and other gases like methane absorb and radiate heat back to the earth, and so it makes it to where you have more heat in between the surface of the earth and the ozone layer. So basically the earth is just warming up. And greenhouse gases also come from electricity generation, okay, and then also transportation, really the exhaust that comes from cars and buses, okay, and big moving things like trains, stuff like that. And then today, the amount of carbon dioxide released in the atmosphere is about twice the amount that remains in the atmosphere. And it's thought that most of this kind of dissolves in the ocean. Okay. So if you look at the carbon cycle here, we've just got a lot of carbon dioxide that's getting into the atmosphere. A lot of it from respiration, from decay, and then also from industrialization, the burning of fossil fuels, destruction of vegetation, so you don't have as much oxygen being produced by plants because the plants are getting cut down. And you do also have some coal, natural gas, oil, things like that. Okay, and those, of course, are reservoirs of carbon. Okay, now, and then carbon dioxide, really, we have to keep that in check because it is a big contributor to global warming. Okay, and so the increased amount of carbon dioxide, other gases, basically it's just making our Earth, hotter as the years go by. Now, dead zones. Dead zones happen when phosphorus and nitrogen from chemical dumping and fertilizers cause an excess growth of microorganisms. Okay, so basically, microorganisms, they love phosphorus and nitrogen because that's food for them. And so when you get an overgrowth of things like algae and fungi, basically it starts to raise the temperature in the water, and it's going to deplete the oxygen and then also kills lots of animal life. Okay. And so you see these dead zones in areas of large population density. Okay. And these zones can also be caused by oil spills, too, not just chemical dumping. Okay. The fertilizer runoff from the Mississippi River, just so you know, not too far from us, has created a dead zone in the Gulf of Mexico for over 8,463 miles. Okay, so lots of pollution out in the Gulf of Mexico and other places, on the earth, over in Europe, and then, kind of near Japan, over that way. Now, biomes are a major type of ecosystem, and it depends on where they are on the earth and how much rainfall and precipitation they have. There is a characteristic mix of animals and plants and vegetation that's a lot of the time determined by temperature and which plants and animals can stand the temperature that's in that biome, where they thrive the best. And biomes form a particular pattern when they're plotted according to their temperature and then also precipitation. And when you look at this, basically, the colder it is and the drier it is, you're going to have the tundra, and then it's going to warm up a little bit for the taiga, and then you have these deciduous forests. Okay, and we live in the temperate deciduous forest, just so you know. And then you've also got woodland and shrubland, and then shrubland, excuse me, and then a rainforest too as it starts to get warmer. And then as it gets hotter, you'll get tropical seasonal forest, tropical rainforest, things like that. Okay, so basically, there are certain areas of Earth where they have kind of a constant temperature range pretty much all the time. Okay, and here's where the biomes, basically where they are located. Okay, and they're organized, of course, by color. The tundras are going to be where it's the very coldest. The taigas are going to be where it's next to coldest. Okay, and when you get closer to the equator, you'll see temperate deciduous forests, you'll see temperate grasslands, and then as it gets closer to the equator here, you'll start to see more rainforests, and it's going to get hotter, things like that. Okay, lots of seasonal forests down here. Okay. And here's some of the biomes we're going to be looking at next. You've got your tundra where it's very coldest, and then the taiga, which is more like upper Canada. Temperate deciduous forest, that's part of the United States and Canada, Europe, okay, and Russia. Tropical forest, that's going to be more towards South America. Shrublands are going to be in the western United States, South America, the west part, and Central Asia. And then the grasslands are going to be, in Africa, part of South America, and then the prairies of North America, kind of like where Kansas and Nebraska are. And then you have deserts that are very, very hot and very, very cold at night. Okay, hot during the day, and then have very low precipitation. Okay, and basically they're distributed, these ecosystems and biomes, depending on how much water and precipitation they get, how much sunlight they get, and defining topical features, whether they have mountains or whether they're at sea level. And both latitude and altitude are responsible for this kind of temperature range. And typically, the closer to the equator you get, the hotter it is. Okay, and the more solar radiation you're going to have. That's it.